Hi, just got done running, so let's do some math. So we are at 8.3, section 8.3. We're doing compound interest. So hopefully this one was less challenging than the last two sections. I feel like the last two sections we were jumping into some fairly new content, but section was just applying the same content over again. So let's see what we got here. Louise has $1,000 that she wants to deposit at her local credit union for 5 years. Credit union offers two types of savings account. Here we go. Account A pays 2.5 annual simple interest. Account B pays 2% annual interest compounded yearly. Which account should Louise choose? Explain. So we will probably have to figure some stuff out, right? So for 5 years, so $1,000, 5 years. So account A is 2% simple interest. So what that means is she's depositing $1,000, and every year she gets 2.5% of $1,000. I guess we should write that as a percent. So 0.025 times 1,000 for however many years. In this case, it's going to be for 5 years. So we can just put a 5 right there. So we pull out our handy dandy calculator. Let's get out of that. Quit. Clear that off. So I know I wrote on the screen, but 1,000 plus parenthesis 0.025 times 1,000. Most of you can probably do that in your head, but I'm lazy. So note here on the calculator, you can just add that 5, just like you can normally, and it's assumed that it's multiplication. So our simple interest at the end of the year, or at the end of 5 years, you'll have $1,125. So that's $125 simply for not spending anything. So let's say account A, she has, what was that number again? Oh, I'm so bad at this. 125, right? Or 1,020 and 125. 1,025. Go away, calculator. Come again when I need you again. So, we could probably look at this. Account B after 5 years. No. Let's just figure out what account B is. So, account B compounded annually. So remember, our formula for interest is A, which is the total amount at the end of the time period, equals P, which is your principal, 1 plus your rate over N, where N is the amount of times per year, and T. And in this case, N is 1, so we can just use P1 plus R, T. So that's what we got. We got our rate. So our principal is $1,000. Our rate is, what was it? 2%. So expressed as a fraction, 0.02 times are brought to the power of 5. So again, pull out that calculator, and we're just going to do 1,000 times 1.02 brought to the power of 5. So our ending total, and again, I'm just writing on the screen. Sorry, it looks weird. 0.08. So which one should she choose? Compounded annually. We have this one. Compounded simple interest with a higher interest rate. You get this one. So by choosing the right bank account, she gains almost $20. Done. Too easy. She just got a $20 bill for being able to do math. So she should pick account A. After 5 years, account A would have a balance of, that's not the right number. So I'm looking at this one. Account A, after 5 years, account A would have the balance of that number, which is what we got, while account B will only have 1104.08. Done. Money, if you will. So I'm going to leave those equations at the top because I have a feeling I need it again. So Ben deposited $600 into an account that pays 4% annual interest compounded yearly. Ben's brother Matt agrees to sell Ben the computer he just bought in 3 years. Matt paid $1,700 for the computer, but its value is expected to decrease by 25% per year. Will Ben have enough money in his account after 3 years to buy the computer, assuming he pays Matt its fair market value? Explain. So this is a two-step problem. Step one, figure out how much money Ben is going to have. And then step two, figure out how much the computer is going to cost in 3 years. So step one, it's compounded annual interest yearly. Sweet. So our principal is $600. Our rate is 0.04. And since it's compounded annually, our n is 1. So, I don't want to say it drops out, but we don't have to worry about it. And then our time is 3 years. So that equals, calculator, show us the way. 600 times 1.04 to the power of 3. Boop. So that's going to equal 674.91. We'll give him an extra penny. We'll say 92. So now we need to figure out the cost of the computer. So the cost of the computer is the exact opposite of our function, right? Yeah. So in this case, our principal, or our initial cost, is $1,700, and it's 1. And this is technically going to be minus because it's expected to decrease by 25%. So since it is decreasing, that's why it's a negative. 2.5, and it's going to be for 3 years. Go, gadget calculator. 1,700. 1.25. So yes, that is what, 0.75 or something? I'm being lazy. Don't judge. So the computer is going to cost $717. Wah, wah. We'll round up for him too. So looks like Ben needs to get a job because he's not going to have enough money. So no, after 3 years, Ben's bank account balance will be 674, which is less than the estimated value of the computer at 717. Guess it's time to get the moolah. So let's see here. This says a deposit earning, the deposit of $250 earns 1.5 annual interest compounded yearly. Find the balance of the account after 6 years. Enter the correct value in the box. So same thing. Our principal is $250. 50. Wow, it's a really weird O or 0. Our rate, so it's compounded yearly. N equals 1. Our rate is 0.015. And it said after 6 years. Go, gadget calculator. That's my face, not a calculator. Go away, face. 250 times 1.015 raised to the power of 6 equals the answer. 273.36. Just in case you don't believe me, I did pull up the answers. 273.36. Boop, boop, boop. 0.36. Next. See, this is way easier than translating functions, right? So a deposit of $4,000 earns 3% annual interest compounded quarterly. Find the balance of the account after 6 years. So quarterly, in finance terms, is the same as quarterly in school terms, versus, as well as the same as a quarter, which is 1/4. So if it is compounded quarterly, it is compounded 4 times a year. So in this case, our n is equal to 4. So our equation is going to look like 4,000 1 plus our rate, which is 0.03, over is compounded 4 times a year, raised to the power of 4 times, how many years is it? 6 years. So there's our equation. So you can simplify that yourself and then plug it in the calculator. I'm just going to shove it straight in the calculator just so that you can see that you can do it. So 4,000 parenthesis 1 minus, I'm going to use another parenthesis, 0.03 divided by 4, close parenthesis again, raised to the power, and I'm going to put this in parentheses just for fun. So if you have an older calculator, you would need to put the exponent in parentheses, so I'm just going to do it as well. So this does all of the math for us. Wait. That seems odd. Oh, I did minus, and I should have done plus. So I looked at my answer here, and I saw that it was less than 4,000, and I was like, that seems like a terrible interest rate. So this is a great opportunity for us to, again, learn something about our calculator. So, okay, I want to take this entry, but change it slightly. So instead of re-entering all of that, I'm going to use the entry button right here. So second entry. So I want to go change that negative to a plus. And then we're going to insert a plus And we got to get rid of that minus sign, so we're going to push the delete button, and we're done. There you go. That seems like a more right answer. Equals 4785. So remember, a calculator is only as smart as the person using it. So 4785. That's not 5. 5.65. Just in case you don't believe me. 4785.65. Money, 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 money! Money! All right, a deposit of $800 earns 4.9% annual interest compounded continuously. Find the balance of the account after 6 years. Enter the correct value to the box. Do not round until the final answer, and round to the nearest cent. So compounded continuously is just a simple, easy, different formula. So go away. So that formula is A equals our principal. Oh, look, E. That seems weird. RT. So I don't think well, I did go over this in the notes because I'm going to go back and put it in. But this is our formula. So again, we've got our principal. So 800 e to the power of our rate, which is 0.0499 times what? T after 6 years. 6 years. So what are we going to do? Go, gadget calculator. I should really learn to write these things in such a way that we can see them when we come over to the calculator. So 800 times E, that's the wrong button. Go away. Quit. 800 times E to the power of, we're going to put this all in parentheses just to be safe, 0.049 times 6. Close parentheses. Solve. So our answer is going to be 1073.43. So when it says do not round until the final answer, that just means that they want you to plug this whole thing into your calculator as opposed to, you know, doing this part in the calculator and then rounding that and then putting that into this bigger equation. So that's what they mean by that, and that's pretty typical. That's why, I mean, we have these machines that can do all of these calculations for us, and we just get a little bit more of a precise answer if we wait until rounding at the end. So just to make sure, bam, too easy. Money, right? Money. So it pays to know math, especially in this situation. So there's a little taste of the world of finances. So if you enjoy this kind of math and you enjoy making a lot of money, maybe finances is a good career for you. So I'll see you in class. By the way, if you use math and make a lot of money, remember your math teacher, Mr. Lin. Just saying. Bye.